So in section 2, we're going to talk about if you have rejected your null hypothesis for an ANOVA test, how do you determine which pair of mean or means is significantly different? So there are two different tests you can potentially run. One of them is called a Scheffé test and the other is called a Tukey test. Both check where a difference lies between all of the means by checking each one against each other, and they give the same result. However, one of them is used when sample sizes are equal, and one is used when they are unequal. So the first one we're going to talk about is the Scheffé test, which you can always use. So if you have unequal or equal sample sizes, it does not matter. You can always perform the Scheffé test. So what you'll do is you pair up each mean and see if they're significantly different. Now, obviously, you don't do this if you failed to reject your null hypothesis when performing an ANOVA test. So the first thing you have to do is find your critical value. And the critical value, you use the one that you did in your ANOVA, except you multiply it by k minus 1, where k is your number of groups. So, for example, if you got that your F critical value was 4, and there were 3 groups, then your Scheffé critical value, which we put SC, would then be 4 times 3 minus 1, which is 8. You then have to find your F statistic for the Scheffé test for each pair of means. And this is where it can kind of get time consuming with the Scheffé test, because depending on how many groups you have, it determines how many pairs you have, which are multiple F statistics. So the way you calculate the F stat is for whichever pair of means you're comparing, you subtract their means and square it. Then you take their within group variance and multiply it by 1 over the sample size for the first group plus the 1 over the sample size for the second group. And you would have to do this for each pair of means. And then you compare your statistic to your critical value and make a determination if it is significant, if the stat is larger than the critical value. So that means if our F stat for our Scheffé test is greater than our F critical value, we reject and we say that that pair of means is significantly different. And you can also go further, because if once you compare all of your pair of means, any that you reject, you can look to see, is there a mean that is common between those rejections? And then you may be able to say which mean by itself is significantly different. Obviously, if you only reject one pair of means, then it's just that pair of means that is significantly different. So let's go ahead and look at a example. So we have data collected on how many steps it takes students to get from their car to the classroom each day. We have LA, Jennifer, and Ian. So to run my ANOVA test, I label each of my means, and we say the null hypothesis is that mu1 equals mu2 equals mu3. And then my alternative hypothesis, at least one pair is significantly different. And then you would run your ANOVA test. So what I did is I go ahead and I ran the ANOVA test and with a level of significance of 0.05, and we have our results. So the only two values we care about here are the F statistic and our F critical value. In this case, our F statistic is greater than our F critical value, which means we reject our null hypothesis. And we would say that there is a significant difference. So there is evidence to show at least one pair of mean steps is significantly different. Now we want to figure out which pair or pairs of means are significantly different. So now we're going to see where the difference lies. So first thing we need to do is figure out the critical value for our set of data. So the critical value, and we're going to go ahead for our Chaffee test, we're going to take our critical value, 3.81, multiply it by our number of groups, 3 minus 1, which is going to give us 7.62. Now we're going to calculate all of our test statistics by hand. And again, there will be another video where I show you how to do the test statistics using something in Google Sheets. So make sure you watch that video as well. So we're going to start with LA versus Jennifer. So for the statistic, we're going to subtract their means, which we can get from the ANOVA test. 734.5 minus 954.2, we're going to square it, over our within group variance, which is 55,040.29 times 1 over, and then there are 4 sets of data, sample size of 4 for LA, and 1 over 5 for Jennifer. Again, it is to your benefit to put this in your calculator in all of one step, and that is going to give us a statistic of 19.36, which when I compare to my critical value is greater, so we are going to reject and say they are significantly different. Now we're going to do it for LA versus Ian. So still 734.5, then minus Ian's mean, 762 squared, over our within group variance, 5,540.29 times 1 over 4 plus 1 over 7, which is going to be 0.35. So that is not greater. So we failed to reject, which means they are not significantly different. And lastly, we'll do Ian versus Jennifer. So we'll have 762 minus 954.2 squared over 5,540.29 times 1 over 7 plus 1 over 5, which is going to give us 19.45, which is again greater. So we are going to reject, and there is a significant difference. Now I want to make some conclusions. So now what I'm going to do is look at the pairs of means I rejected. And I rejected LA versus Jennifer and Ian versus Jennifer. And we want to see, is there a common person in that pair of means? And that person is Jennifer. So for my conclusion, I can actually say there is evidence to show that Jennifer takes significantly more steps than anyone else. been only rejected once, obviously I would just say that there is evidence to show that there is a significant difference in the number of steps taken between whichever two people I've rejected for. Now let's talk about the Tukey test. So if you have equal sample sizes, it is actually better to perform a Tukey test than the Scheffé test because the Tukey test is more powerful. So the way we calculate our critical value for a Tukey test is actually using a table, and I will make sure that you have the table. So we use something called table N, where we have K equals our number of groups, and our degrees of freedom is capital N minus K. So remember, capital N is the total number of pieces of data you have minus your groups. And then we calculate something called a Q statistic for the Tukey test for each pair of means. So the numerator is just a subtraction between the means that you're comparing, and your denominator is the square root of the within group variance over N. And I don't have to take into account like 1 over N like I did before because you have the same N for all of your groups. So the formula is much nicer. And then what you do is you compare each one to your critical value and make a determination if it is significant, if the stat is larger than your critical value. Now, a couple of things here. Because we don't have a squared in the numerator here, our difference, we could get a Q stat that is negative, and our critical value is always going to be positive. So when we're trying to make our determination, we're actually going to look at the absolute value of Q and compare to see if it's greater than the absolute value of our Q critical value. And if that's true, then we reject, and we can say there's a significant difference between that pair of means. So we do want to look at the absolute value of both of those. The example we're going to use is the moose example from our last section of notes. So just kind of to review, we had the amount of time that the moose spent with its feeding items, and when we perform the ANOVA test, we have each of our averages, which are 4.6, 8.83, and 3.67. And when we look at our ANOVA, we have our F statistic and our critical value, which led us to reject. And then we want our within group variance, which is the 7.68. So now let's go ahead and figure out which are different. So the first thing I need to do is go ahead and calculate my critical value. So using our table, our number of groups is 3, and our degrees of freedom, total number of pieces of data, 18, minus 3 is going to give us 15. So we're going to find 3 across the top for our number of groups, and degrees of freedom 15, which is going to give us a critical value of 3.67. And even though it isn't stated, we have an alpha of 0.05. So let's find our statistic for the water versus the Lucky Charms. So we're going to take the mean, 4.6 minus 8.83, over our within the square root of our within group variance, 7.68 over 6, which is going to give us negative 3.74, which again, we want to compare its absolute value. So the absolute value of negative 3.74 is greater than our Q critical value, which means we are going to reject, and they are significantly different. For our second example, the water versus the seaweed, we'll have 4.6 minus 3.67 over the square root of 7.68 over 6, which gives us 0.82, which if I compare the absolute value of 0.82, it is less than our critical value, which means we fail to reject, and it is not significantly different. And then our last example, our last group, the charms versus the seaweed, we have 8.83 minus 3.67 over the square root of 7.68 over 6, which gives us 4.56. So we do the absolute value of 4.56, which is greater than our critical value, which means we reject, and it is significantly different. So now we want to make a conclusion. So of the two that I rejected, we rejected water versus charms and charms versus seaweed. So again, just like with the Scheffé test, I look to see what the common item is, which in this case is Lucky Charms. So we'll say there is evidence to show that Lucky Charms is used significantly more than the other items. And again, make sure you check out the videos. There will be 2 of them that talk about how to perform the Scheffé and the Tukey test using Google Sheets. So I'll do each of the examples we just did in the notes using Google Sheets so you can see how they're performed using Google Sheets.